Hello everyone, welcome to Equal To, and this is the last video in our matter in our surroundings playlist, and we have completed the entire lesson and all the in-text questions there. Now we are moving on to the exercise questions. I hope you have seen all the previous videos. If you haven't, I'll give you a link here. You can go and check them out. Now we'll move on to this video. We'll be solving in-text questions from every single topic that we have covered in this chapter. I hope you are clear with those topics. Now before moving on to it, if you have any doubts in any of the above topics that we have already discussed in our playlist, please put them in the comments and I'll get back to you as soon as possible. Now we'll move on to the questions. The first question is, convert the following temperatures to Celsius scale. Again, we have solved similar questions already. It's quite simple. We know that 273 Kelvin is 0 degrees Celsius. So to convert 293 Kelvin to Celsius, you have to subtract 273 from it, which gives you 20 degrees Celsius. 293 minus 273. Now to the second part of this question, we have 470 Kelvin. Again, the same logic applies. 470 minus 273 gives you 197 degree Celsius. So that is how we solve this. Now to convert this in reverse from Celsius to Kelvin, you have to add 273 to it. Okay. Now we are moving on to the next question. So the next question is, convert the following temperature to Kelvin scale. Obviously the reverse, right? The first part is 25 degrees Celsius. So to convert Celsius to Kelvin, we are going to add 273. So 25 plus 273 gives you 298 Kelvin. And the second part is 373 Kelvin. 373 plus 273 gives you 646 Kelvin. So this basically is the conversion. You just have to remember that one single number 273, if you add it to Celsius, it gives you Kelvin. If you subtract it from Kelvin, it gives you Celsius. That is all to it. Now we are moving to the next question. Give reason for the following observations. Naphthalene balls disappear with time without leaving any solid. So you know naphthalene balls that we put in our sinks, basically where we wash our hands, we put there. You know that. And that is basically used for insect prevention or something like that. So what exactly happens? You never see these naphthalene balls become a liquid or making a mess there. They just disappear. Okay. So something that we have seen already that we relate to this is called sublimation. I hope you have seen this. Okay. So sublimation is the concept where the solids, they directly get converted into gas. They directly evaporate into air without even converting into liquid. This is what we call sublimation. And naphthalene balls, they are very volatile. They easily get converted into gas and they sublime into the air. Okay, that is the reason naphthalene balls disappear without leaving any, like the whole of it gets converted into vapors. Okay, so that is the reason. Now we are moving to the next question, which is, we can get the smell of perfume sitting several meters away. Okay, perfume is basically in liquid form, right? So when you try to spray it on, it has a very volatile solvent. Solvent is the base liquid in which your odor is mixed into. Solvent is a liquid. So you could say water is a solvent. If you basically it comes in the concept of solutions that we'll see in later chapters. In simple terms, when you try to create a solution, that is when you try to mix something in a liquid, the liquid is what we call a solvent. So what here they are saying is that perfume has a volatile solvent. So the solvent that they are using in perfume, it's highly volatile, meaning it gets converted into gas very easily. So it gets converted into gas very easily, and obviously gas molecules have very high kinetic energy and they move very fast. And that is why perfume can reach several meters away. When someone puts perfume and comes before you, you will be able to smell them even before they are close to you. So this is the reason for that. Now moving on to the next question. Arrange the following substances in increasing order of force of attraction between the particles. Water, sugar and oxygen. Now water here is liquid, sugar is solid, sugar is solid and oxygen is gas. So we obviously know that the order of forces gas has very low force of attraction, water has relatively better force of attraction, that is liquid, and solids have maximum force of attraction. So O2, oxygen, water and sugar, that is the increasing order of force of attraction. I hope you got this. Now moving on to the next question. What is the physical state of water at 25 degrees Celsius, 0 degrees Celsius and 100 degrees Celsius? 25 degrees Celsius is above the liquid point, that is above the melting point of water, so it obviously be as liquid, and it's way below than 100 degrees Celsius, which is the boiling point of water. So in this frame between 0 degrees Celsius and 100 degrees Celsius, water will obviously be a liquid. That's quite clear. So at 25 degrees Celsius, water will be a liquid. At 0 degrees Celsius, it will be a solid or liquid. It depends. So 0 degrees Celsius is the melting point of ice. So at 0 degrees Celsius, it starts melting into ice. But after reaching 0 degrees Celsius, the heat that you provide will not actually increase your temperature, right? We have already seen this so many times. I hope you remember the logic. The heat that you provide, it's used as latent heat. It is used to overcome the force of attraction between the particles, and it gets converted into liquid and doesn't actually increase the temperature. So at 0 degrees Celsius, some might have gained the latent heat and become liquid, some might not have, so they remain as solid. So at 0 degrees Celsius, they remain as both liquid and solid. So basically what you could say is that at melting point, it would be liquid or solid, and at boiling point it would be liquid or gas. The same principle, the same reason applies. Some might have gained latent heat, they would have become gas at 100 degrees Celsius. Some might not have, so they remain as liquid. So this is basically it. Now moving on to the next question. Give 2 reasons to justify water at room temperature is a liquid. I don't know, like it's very simple. I don't even have to explain this. Freezing point is 0 degrees Celsius, boiling point is 100 degrees Celsius, room temperature is basically 24-25 degrees Celsius, I guess. So it would add up, like at 0 degrees Celsius it would be freezing, at 100 degrees Celsius it would be boiling, anywhere in between it will just be remaining as liquid. So I think it's quite clear. Moving on to the next question. An iron almirah is a solid at room temperature. Almirah is basically an iron shelf. Okay, I hope you understand what I'm trying to tell. Obviously, iron has a very high melting point. Obviously, it cannot melt on room temperature. Okay, so that is why they remain as solid. Iron has a very high melting point. I think you know that. At that melting point, even it wouldn't look in the color that it would look when you normally see it, right? It would be so red. Very high melting point. So that is why they stay as solid at room temperature. Moving on to the next question. Why is ice at 273 Kelvin more effective in cooling faster than water at same temperature? So ice at 273 Kelvin doesn't have latent heat. If it has latent heat, it would have become water. So it can gain more energy from you, obviously, okay, because it doesn't have latent heat when compared to water at 273 Kelvin, which it has latent heat. So 273 Kelvin is basically the melting point of water, right? 0 degrees Celsius. So at that point, ice doesn't have latent heat and water does have latent heat. Since ice doesn't have latent heat, it can absorb more heat, and that is why at the same temperature, ice is more effective at cooling than water. I hope you got this. Moving on to the next question. What produces more severe burns? Boiling water or steam? Obviously, I think you know the answer. It's very similar to the previous question. Boiling water doesn't have latent heat, so it's still boiling, it still is in water state, but steam is vapor, so it has gained latent heat. So obviously steam has higher energy, so steam is at higher temperature as well, so steam can cause severe burns when compared to boiling water. Steam has a lot more energy. Steam is significantly at higher temperature when compared to boiling water. Boiling water doesn't have latent heat. If it had gained latent heat, it would have converted into steam, it would have converted into water vapors, but it hasn't. So obviously steam has higher energy, steam has higher temperature in it, and that is why steam can cause severe burns. I hope it's clear. And obviously boiling hot water, it also will cause burns. So don't pour it. Try to be careful around it. Okay, moving on to the next question. So this question is quite, I know it's a lot to see on the screen, but just bear with me. It's very simple. This is everything that you have seen already. You don't have to learn anything new here. Just the state of conversion and the names for it. I'll just go through this one by one and you'll remember it already. So when solid, when it converts to liquid, it's called melting. Just remember ice. Okay. For some of these ice works, some of it doesn't. But for solid to liquid conversion, ice when converts to water, we say it melt. Ice melts. Okay. Another name is fusion. We have seen this already. Melting or fusion, they are both same. And obviously, since it is becoming a liquid, you can call it liquefaction. It's just a fancy way of saying it. So liquefaction, melting and fusion. Liquid, when it converts to gas, we call it as vaporization or evaporation. So water evaporates. It gets vaporized. Okay. So liquid to gas is called vaporization or evaporation. Now the third thing is gas to liquid. Gas, when it converts to liquid, that is what we call as condensation. So gas to liquid is called condensation. And liquid to solid is called solidification, because you are again converting it into solid. Solidification. I hope it makes sense, right? Solidification. Solid directly, when it converts to gas, it's what we call sublimation. We have just saw it with, naphthalene balls. So solid, when it converts directly to gas, we call it sublimation, and gas, when it's converted to solid, it's called deposition. So gas, when it's converted directly to solid without converting into liquid, we call it as deposition. So solid to liquid, melting, fusion or liquefaction. Liquid to gas is called vaporization or evaporation. Gas to liquid is called condensation. Liquid to solid is called solidification. Solid to gas directly, skipping the liquid part, it is sublimation, and gas to solid directly is called deposition. So that is it. I hope it's clear, and it's better for you to remember these things as well. I think it's easy. If you have followed all the videos right from the beginning, we would have learned this one by one, and you already know this by now. Okay. Now we have completed everything in this chapter. This is the last part. So these are the quantities, their units and their symbols for these things. For temperature, we have already seen Kelvin, and the symbol for Kelvin is K. We would have already seen it in the questions, problems. So temperature, Kelvin, K. Length, obviously we know it's meter and it's m. Mass, we measure it in kilograms. It's a quantity similar to weight. We will be learning more about mass in later chapters. So mass, SI unit is kilogram, kg, and weight is Newton, N. So as you can see, we are not measuring weight with kg, but I told you mass is similar to weight. Okay, so I think these things might be confusing to you, but it basically comes in a later chapter. We'll definitely go through that, and I'll make it clear then, but just keep it in mind. Weight is a form of force. Okay, weight is a form of force that you apply on something. So if you stand on the surface of earth, we are already doing that. We are not standing anywhere else. We are just standing on the surface of earth. So we are exerting some force on earth with our mass. Our body has a mass, and we are exerting some force on earth because of it and because of the gravitation force. So that is why weight is a force, and that is why we call it as Newton is the unit for it. I think I went way past our syllabus. Just don't consider it now. We'll get back to that later. And then the next thing is volume. Volume is cubic meter. So basically length into breadth into height, and all these three things are length, which is measured in meters. So it's just meter into meter into meter gives you meter cube. Okay. The next thing is density. So density is kilogram per cubic meter. The definition for density that you have seen in the earlier part of this chapter, I hope you remember it. Basically, it's mass per unit volume. So at the numerator you have mass, which is kilogram. At denominator you have volume, which is meter cube. So it's just basically kilogram per meter cube, kilogram bar meter cube slash meter cube, and that you can represent as power minus 3. Okay, for volume it's plus 3, and for density is kilogram kg m power minus 3. It just represents that it's supposed to be in the denominator, below part. And the next thing that comes is pressure, Pascal, PA. Okay, Pascal is the standard unit, but we also use atmospheric pressure, which is basically 1.01 into 10 power 5 Pascal. We have seen this in the previous video. I hope you remember it. Now that is all the questions for this chapter. We have covered every single theory topic in this. We have covered all the activities. We have covered the in-text question and also the exercise questions. I hope you got to know this chapter and the techniques here, the theory here very well. If you have any questions, please feel free to put them in the comments and I'll get back to you as soon as possible. Maybe if it's a complex question, maybe I'll even make a video on it, please. So please don't hesitate. Please put your doubts in the questions and I'll get back to you. And if you like this video, please like it and consider subscribing to Equal To. More videos are coming soon and more chapters as well. If you have any suggestions, put them in the comments as well. Thank you so much for watching this video. See you in the next one. Bye for now.